Hi, welcome to the tutorial Machine Learning Models with Python. I am Arnab Chakraborty from UpDegree, and in this video we are going to cover categorization of machine learning coordinates. So here is the respective diagram for us. Here we are having two column heads, supervised learning and unsupervised learning. We know that in the previous video also we have discussed, in case of supervised learning our data will remain labeled and it is task driven. That means some feature attributes will be there, outcome attribute will be there, outcome attribute will have the different classes for the output, and it is totally task driven. That means on the training data set my model will run, and on the unseen data set the model will predict. In case of unsupervised learning, you can easily find that in case of unsupervised learning, here there is no output column, so my data set is not labeled. And in this case what is happening, we are trying to find out a data pattern in our data set. This data can be of the type of discrete, can be also of the type of continuous. So in case of supervised learning, in case of discrete data, we can go for classification or categorization. In case of unsupervised learning, for discrete data we can go for clustering. In case of continuous data set, in case of supervised learning we can go for regression, and in case of continuous data set, in case of unsupervised learning we may go for dimensionality reduction. So for all these categories we'll be having a detailed discussion, but at present let us discuss what is dimensionality reduction. In statistics, machine learning and information theory, dimensionality reduction can also be called as dimension reduction, is the process of reducing the number of random variables under consideration by obtaining a set of principal variables. So in our data set we might be having different feature attributes, but here we'll be considering those feature attributes which will cause our system from getting overfitted or underfitted. That means we'll be considering only the principal variables. So principal variables means the main variables on which my predictions are varying, my outcomes are actually really getting affected or really getting influenced. So those principal attributes will be considering, and rest attributes will be considered as non-principal attributes and variables, and they will be discarded so that my model can predict in a perfect way. So it can be divided as into feature selection and feature extraction. Feature selection means some of the features will be taken care of, some of the features will be discarded for the prediction purpose, for the learning and training purpose. And feature extraction means from the given feature value we shall be extracting some second layer of information or second layer of features, and that is known as feature extraction. We shall be discussing everything into details with some diagrams in our succeeding lectures. So let us go for the classification and clustering. So we know that classification and clustering is available in case of discrete data set. So example is that this is an example of classification problem where there are two classes, one is a low risk, another one is a high risk customers. The information about a customer makes up the input to the classifier whose task is to assign the input to one of the two classes. And after training with the past data, the classification rule learned may be of the form is that, so here we have plotted along the x-axis the income and along the y-axis the savings. So now when the income is more than theta 1 and when the savings is more than theta 2, that means in this particular zone, so when the income is more than theta 1 and savings is more than theta 2, so here we can consider this one as the low risk zone, and the rest part of this graph of this particular plottings can be considered as a high risk zone. So if income is greater than theta 1 and savings is greater than theta 2, then low risk else high risk. So there is a good example of classification and clustering. So you can find that here we have plotted multiple different points and they have got classified into two classes, that is a low risk, another one is the high risk. So this is a good example of classification and clustering. So here we are having the regression. A regression problem is when the output variable is a real value and such as dollars or weight instead of a class. That means we know that in case of regression, this regression can be applied when our data set is continuous. And you know that in case of supervised learning, in when the data set is continuous, we can go for the regression. So estimate the relationship between a dependent variable, one or more independent variables or predictors. So here you can find that along the x-axis we have plotted the screen size, that is x. Along the y-axis we have plotted the y, that is the sales figures, and here for different value for x we have plotted the different value for y. So you see these are the respective points are there, and now this is the known as the respective scatter plot. So this graph is known as a scatter plot where we have plotted x and y here, and now this is we are going to find out that what is the correlation between these 2 points when x is increasing, y is decreasing or increasing. So that will be decided by the correlation coefficient, and here we have suggested one line which is the best fit line for these respective points, and this line is known as the regression line. So what will happen from this regression line, from this respective slope of this line, it is quite obvious that when the screen size is increasing, the sales figure is decreasing. So they are having the negative correlation coefficient here. So now another point is very important. For a new value for x, we can predict the respective value for y. So for a new screen size, we can predict the respective sales figure. So sales figure for a television model can depend on several factors like our screen size, display type, brand, resolution, technology used, etc. And here we consider just one attribute, say screen size, and plot the corresponding prices. That is along the x-axis we are plotting the screen size, and along the y-axis we are plotting the sales figures, and we try to find the relation, that is a function that best matches between these two variables. And from here we can also go for predictions and forecasting. So this is one of the examples of our regression. So here we are having the dimensionality reduction. So it is the process of reducing the number of random variables under consideration by obtaining a set of principal variables, and it can be divided into feature selection and feature extraction. So in our data set we might be having say hundreds of different feature attributes, but we shall be taking those feature attributes which are actually decisive for taking the output into consideration. So these feature attributes will be known as the principal feature attributes. So rest non-principal attributes will be discarded and will be working with these principal attributes. Now the point is coming in mind that how can I guess that which feature attributes will be the principal feature attributes. So feature selection approaches try to find a subset of the original variables, also called the features or attributes, and it is about choosing some of the features based on some of the statistical scores. So here we shall be applying some statistical score functions on these feature attributes, and those feature attributes will be taken into consideration, will be treated as principal feature attributes whose statistical score will be higher, and those feature attributes will be discarded, will not be considered in the training or learning or in the forecasting purposes. Those will be having the statistical score with the lower values. So feature extraction transforms the data in the high dimensional space to a space of fewer dimensions. It is usually using the techniques to extract some second layer of information from the data, and as example interesting frequencies of a signal using Fourier transform. So here we are having one signal. We know that one signal is comprising of different other participating signals are there, and their interference will make the ultimate signal in the required shape. So now from the signal whatever we are getting using Fourier transform or using some other techniques, we are trying to find out what are the interesting frequency components and frequency available in the signals to form the mother signal in this particular case. So in this way we are going for our second level of or second layer of information from the data, and that is known as feature extraction. Dimensionality reduction helps in data compression, reduces computational time, and removes redundant features. That means in this case, if we go for the dimensionality reduction, so what will happen? We are dealing with the principal attributes only. So obviously we are discarding some of the attributes or most of the attributes from our data set we might be considering say 4 to 5 principal attributes. So our computational complexity will get reduced. Our complexity, that is the time complexity for forecasting, for the learning, will get reduced, and removal of redundant features will make my system more intelligent and more predictive. So in this way, we have discussed that what are the categorization of machine learning coordinates. So in that next video, we are going to cover the one hot encoding.